Hello and welcome to this Elektor webinar. I'm your host, Brian Tristan Williams, and today we're diving into the fascinating world of audio processing with the Elektor Audio DSP FX processor. Nice activity going on in the chat room already, and joining me now is Clemens Valens. He's the mastermind behind this project. Hey Clemens, how are things going?
Hi Brian, I'm fine.
Great. I'm looking forward to this hour. That's quite a complex project you've got going on there. So joining us now as well is our editor-in-chief, Jens Nickel, who will bring his insights, but more importantly, he has questions. Jens, how's it going in Germany?
I'm fine, Brian. How are you?
I'm great, thanks. It's a bit hot down here in South Africa. It's about 32 degrees outside, but we'll get through it. So together, we'll explore the features and applications and capabilities of the powerful board. It's this powerful board right here that Clemens, like I said, he was the mastermind behind it. And so let's get started. First of all, we have a sponsor, and our sponsor today is Omnetics. Get that banner up on screen, please. Okay, Omnetics Connector Corporation, they're a leading designer and manufacturer of high reliability micro miniature and nano miniature electronic connectors with over 40 years of experience. They're based in Minneapolis in the USA, and Omnetics specializes in producing QPL approved connectors for industries like military, space, aerospace, and instrumentation. Their innovative flex pin contact ensures top-notch performance, making them a trusted partner for high-tech applications across the globe. For more information, you see the URL on the banner. Go to www.omnetics.com. Now, I should mention giveaway. We do have a great giveaway. And there's our giveaway page. We'll give the URL later, and we'll give the code word later. So just visit this URL here. You put in your code word, your email address, your country, prove that you're not a robot. And today we are giving away one of 5 books about practical audio DSP projects with the ESP32, which is right on topic. And we'll get back to you on that later when we give you the code word. Now, we'll move on to segment 1 with Clemens, and he'll give us an overview of the board. That's this board here, but he also put together a great article, which I'll be showing you a bit of as well from the magazine. But this is the board as it stands in our store. As you can see there, well, I won't go into it because we have the expert, the genius behind it with us. But yes, it's a small board and it does effects, and it's got even MIDI in and out there on the jacks on the left and right. But Clemens, I'll leave the expertise to you. Why don't you tell us a bit about this board and why you felt it was necessary?
Yes, well, necessary, that's also a good a relative thing, of course. But yeah, the idea came because some 10 years ago, we did a board for the DSP, the AD-AU7001. It was based on the through-hole components, and it only had the DSP on it. And it became quite popular, and many years after, I still got questions about this board. And so after a lot of hesitation, I decided finally to redo the board, this time all in SMD, and make it a little bit more practical. So the original board only had 4 potentiometers and the DSP, and that's it. And I decided I wanted to have a more practical board. So I started with the DSP, put it on board with the potentiometers. And then I thought, well, it's a bit of a shame because it's so complicated to program this DSP. You have to put it in EEPROM, but there is no good program for that available. So I thought to put a microcontroller on the board to program the EEPROM. That was first an Arduino based on with an ESP32, the ESP32 Arduino board, I forgot the name. And then I realized that That board didn't have Bluetooth, audio Bluetooth, so I switched to the ESP Pico kit, ESP32 Pico kit, which can do audio Bluetooth. And I also thought when you have potentiometers and it is all intended for music, you might as well have a MIDI input, so you can use the CC control messages to control the DSP instead of turning potentiometers. So I put a MIDI interface on the board. And now that I had an ESP32 with Wi-Fi capabilities and Bluetooth, and Sigma Studio, the program that you use to develop algorithms for the DSP in, can program the DSP over Ethernet. And so with the DSP, the ESP, it's complicated, with the ESP on the board, I could upload on the fly programs to the DSP from Sigma Studio to the DSP. So that made algorithm development much easier.
Clemens,
and once you have that, I'm sorry,
Clemens, I think you mean via a Wi-Fi connection, wirelessly.
Yes, what did I say?
Ethernet.
Oh yeah, well, it is Ethernet, but it's over Wi-Fi.
Yeah,
it's wireless Ethernet. So it is TCP/IP, I should say, actually. So we have a TCP/IP connection from the computer to the DSP with the ESP32 in between. So you can develop on the fly algorithms for the DSP. And then I also wrote a little program so that you can also program this algorithm into the EEPROM instead of going through another an external programmer. So that's how this board developed. And in the end, you can look at it another way, which is this is an ESP32 with a powerful audio codec. So you can also use it as simply as for instance, a Bluetooth streaming device. But that's sort of that came in for free. Let's put it that way. The basic idea was to have an easy programmable ADA U1701 based DSP board.
Did I understand it right that you either can program the DSP on the fly directly from Sigma Studio, for example, for development purposes, or you can use the ESP as a bridge to upload the algorithms in the EEPROM, and then you can completely disconnect that device and it will be always powered on with the right, okay.
Exactly, you can use it as an EEPROM programmer for the DSP or as an interface, a wireless interface between Sigma Studio and the DSP. But you can also use the ESP32 to generate audio, use it as a synthesizer or an effects processor or what else, and send audio over I2S to the DSP. You can also receive audio over I2S from the DSP. So actually you have now two processors that can work together or separately or independently on audio.
Can you say something about these connectors we can see in the picture on the right side?
So the board is, this is how if you buy it in the shop, this is what you get. These connectors are not mounted because the board is compatible with an enclosure, cheap plastic enclosure, but the enclosure is not very high. And so if you want to put the board in the enclosure with the ESP module on it, if you have the connectors, then it's too high and it doesn't fit inside the enclosure.
I see.
So that's why the connectors are optional. They are provided in the kit, of course. And same for the potentiometers. You don't need those potentiometers. Only the people who really want, they can mount the potentiometers, because you can also control over MIDI, or there are also algorithms that don't need potentiometers. And if you don't have potentiometers, then you don't have to drill holes in the enclosure.
I see, but these jack connectors we have already seen on the image.
Oh, yes.
What is the purpose?
Yes, so we have on this side, we have two audio outputs, stereo, or 4-channel outputs actually. There are 4 output channels. These are the audio input channels, 2. So there are 2 inputs and 4 outputs. The DSP has 4 outputs. And this here one is a TRS MIDI connector. And here we have a power connector.
So, Clemens, if I could ask if we have a look at that kit again. You've got a bunch of, you say the potentiometers are optional. Now, I understand the need for putting those surface mounted chips on the board because not everyone's proficient at that. But the power jack, that looks like a through-hole component. Was there any rationale between which component should come ready fit and which the user would have to put in by themselves?
Yes, of course. The idea is that the board as is, without the optional components, can be used. So the power connector, which is compatible, by the way, with those guitar pedal stump boxes power supplies. So the center pin is ground, if I'm not mistaken.
Yeah, according to the diagram on the board, it is, which is unusual. But like
that is unusual.
Mentioned previously, I've had Roland equipment, like Roland keyboard, and they're the same. Positive.
Yes, so it's not unusual. It's unusual because people misunderstood, in my opinion, the connector, but it's totally common in music equipment.
Is
So
there
that's
a
why
polarity?
that connector is mounted.
Is it safe if you mix up the polarity?
Yes, there is a diode. You can see it right behind the connector.
Okay.
It's called D1. It's in the top left corner of this photo. There is the polarity protection. And then on the right, top right, there is also a header. The header is exposes the I2C bus of the DSP and of the board. And so if you want, you don't need to use the ESP module. You can also use the original Arduino-based programmer that we published 10 years ago. You can connect it to that connector and then program the EEPROM. So this board can also be used totally without ESP32 module if you want.
Okay.
Well, that's great. And if I return to the bottom left here, that is an opto isolator, right?
Yep.
So
Yes.
I know these are small details for you, but I'll tell you why I ask these silly details. I took a photo right now during the show. I'm sitting here with a keyboard in front of me that I'm busy experimenting with, and it has both USB MIDI, but it also has the old-fashioned 5-pin DIN, and I believe those are 5-volt TTL signals. So of course I don't want to blow anything up now. While we're here, if you zoom in, you can see our chat. Hello to Baltic Lab and hello to Bruno Peters from Hemixem, Belgium. But Clemens, how can you assure me of the compatibility between different MIDI sources? I mean, you've got the old-fashioned TTL, but you've also got the ESP32 running on 3.3 volts. So, what are the dangers there?
Well, normally there are no dangers because MIDI was designed to be safe, and that's why there is an optocoupler. So on the input, you can put anything up to, I don't know when the LED will break inside the optocoupler, but so it's compatible with normal 5-volt MIDI. And the output, the MIDI output drives another optocoupler. So it should not be in direct contact with other equipment, only through an optocoupler. The output is 3-volt 3 compatible, and it has a series resistor, so it won't blow it up easily. But of course, it can be done, but it's intended as a normal, standard MIDI port with optocoupler. And the format is it's TRS, except that this is a 4-way connector, so you have it's the TRRS. That's because it's the same connector as I use for the audio, so then you have only one connector instead of 2 different references. But it's basically normally it should work with a normal TRS MIDI cable.
Is there equipment on the other side, or do you have some equipment on your table which also has this MIDI interface with TRS or the TRS?
No, I have a adapter cable somewhere. I don't know, not on my desk.
So you have an adapter cable for this 5 volt. You have an adapter cable for this.
Cables are available. That's nothing special.
Okay. You mean an adapter to this 5 Pole DIN
Yeah, that's
connector.
it's not an adapter, it's just a cable. It's a
Yeah.
MIDI cable with on one side a DIN connector and on the other side a TRS cable. Those cables are, you can buy them online or in the music store.
Okay, here's a populated board, obviously without the ESP board plugged in. And you've mentioned that there are different kinds of enclosures that a user might want to use. So obviously some of these components are, you know, they're optional depending on your enclosure. What enclosure did you end up using yourself, Clemens? Because I don't see one listed on the sold product.
Well, I haven't used an enclosure. I prepared it for this. This is only the bottom. I top somewhere lying around.
While Clemens fetches his samples, just want to say hi to everyone in the chat. And there's a lot of you from Kent in the UK, from the Netherlands, from Guyana on the Western Hemisphere. And if you have any questions, just drop them in the chat and we'll be sure to get to them before the show is over.
It's just a standard Hammond box to shell. Here you the short sides are removable. You know, you call them side panels like this, so you can drill holes in it for the connectors, and then the top shell just goes on like so. And it's nicely. One side you can leave open, and this one is for another project. I use this box for other projects. It's very practical.
Nice
Good
and neat.
dimensions, and you can. So the DSP board fits right in, and if you have the holes in the right place, then the potentiometers stick through. And this is showing now I cannot close it. That's because the ESP module is mounted on its connectors, which makes it too high. It's complicated to show this in mirror image. Yeah, I hope you can see it.
It's mirror image for you, but it's mirror image for you, but we're seeing it just fine. The
okay.
power jack is on the left for us.
So this assembly is too high to close the box. So if you don't mount the ESP module on the headers, then the enclosure will you can close it. This enclosure is available also in shiny, in translucent blue, and red, I think also. Which is practical. Well, there aren't a lot of LEDs on the board, but there is one. So you can see the LED shining through the enclosure.
Yeah, I like that about the Home Assistant product. Semi-translucent cover. And of course, you did this article for the November-December edition, and there we see another example is aesthetics. The board you've pictured here is blue, whereas the one in the Elektor store is green.
Yeah, the other was intended to be blue, but we changed our minds too late, and so it is green.
And at the bottom of the board, it's written DSP 3.0 volt, ESP 3.15 volts. What is the significance of listing that on the board itself?
Oh, that's for the, if you zoom, or I can show it from the camera, there's a trimmer. No, this is not easy. Well, no, that's not working here. Here is it's for the potentiometers. It's an adjustment point.
Okay.
Because the potentiometers, you can either route them directly to the DSP or to the ESP. And the ESP has a slightly different dynamic range for the analog input. So with this trimmer, you can get the best of the dynamic range out of the potentiometers.
Awesome. And looking at your project here, it seems like you used the Arduino IDE to program the ESP32.
Yeah, that's right.
And there's a block diagram for those of you watching. Now, Sigma Studio, I don't know anything about that. What is Sigma Studio, Clemens?
Yeah, well, Sigma Studio is it's a graphical programming tool for the DSP, the ADAU 1701, or for the whole family of that type of DSPs actually, because it's one of a family. And it's a graphical tool. You have blocks, you drop them on a canvas, and then you draw wires, virtual wires, and that is your program. And then you compile it, and it will upload the compiled program to the DSP and execute it. I can show it to you if you want. I can.
Yeah, if you take us down the Sigma Studio road.
No, I have
an example of the Arduino. I'm just looking at the photos of Sigma Studio.
But in the meantime, we can come back to these Arduino programs because Clemens, you also wrote examples for that board. And as I understood, there's code for the ESP32, and also there is a hex file which is directly used to put it in the DSP then. Have you written these programs yourself, or have you got it from, for example, Analog Devices, or modified it?
The software support for the board is indeed an Arduino library. I prefer Arduino to the IDF. That's I think it's too complex. So I created an Arduino library that's you can download from within the IDE. It's available in the installable libraries list of Arduino. And when you do that, you can also add examples to the library. So the library comes with examples. And in these examples, the examples consist of a DSP program and a ESP32 program. And so in the folder where these examples live, there are also the Sigma Studio programs for the DSP hex file that is included in the example.
So you made an official Arduino library. How is it going? How do you get a library to get officially available in the Arduino IDE?
Well, it's not an official library, of course, because only Arduino can make official libraries. It is a user-contributed library. There is somewhere on GitHub, I think there is a list where you can issue a pull request for your library. There you have to provide the URL of your library. It's probably most of the time that will be your own GitHub repository. So you put your library on GitHub, and then you have to conform to a certain number of requirements. So you must provide a properties file and release, of course, and some other things. So you have to get the format right. That is basically the most complicated part. And then this Arduino, they have a robot. Every day they go through the list of user-contributed libraries, and they check if they are available, if they are downloadable. Or I don't know exactly what they do, but they check if it is working. And if you have everything right, then your library shows up in the list of downloadable libraries. So it's an automated process, and the first time is a bit complicated to understand what exactly you have to do and how. But once you've done it, it's really practical. And the good thing of this all is, of course, that it's you don't have to host it. I'll provide a link to everybody. You can just tell the people to use the Arduino IDE and download it. But also updates are managed automatically. So if you update your library and you update the properties file, the version number, and you create a new release, then Arduino, the IDE, will propose to all the people who have this library installed that they can upgrade their library to the latest version. Yeah, there you have it. As you can see, I have some versions. It is version 0.2.0. If you click on version, then you can see the old versions. And that's in the beginning where this goes wrong. The first time you have version 1, and then you think, oh well, actually that should be version 1.1, and then you make version 1.1 when you forget to update something, and so it should be version 1.2. And so but once you have figured it out and have the process going right, then this is really practical. And so if you install this, then you get also the examples, and in the examples you will find the Sigma Studio code and the algorithms for Sigma Studio. There are several examples.
Have you written these algorithms yourself, or did you use?
Some of them I did, indeed, because they are examples. There is a Sigma Studio algorithm that's really simple, that just pumps I2C audio from the input to the ESP and from the ESP to the output. And I make that on 2 sample rates, so you can have it on 44.1 and 48 kilohertz. And so those are very simple algorithms, and they are in there. There are also some algorithms that we ported over from 10 years ago. And I played around with some oscillator stuff in the DSP, and that's also available. And yeah, so basically everything in there I made myself with the help of what I found on the internet.
Awesome. And I think you've just pretty much answered this, but just for clarification, a question from Kieron McBean, who's coming to us from Guyana. Can the library be installed from the Arduino IDE library manager?
Well, that's
I guess
exactly
the question would be how much extra do you need to do external to the IDE?
Nothing. This is like it is showing here. You can download it from the IDE. It's available inside the IDE. Straight
and simple, already available in the.
Like, I don't know who has Arduino running on his computer. Is it you, Brian, or Jens?
Yes, I do.
Yeah, you typed in Elektor in the search box, and then it shows up.
Cool. Well, that does simplify things quite a lot. No having to download and then integrate the libraries manually. So I put
the only thing is that some of these examples included in this library, they contain other libraries, and not all of those are available in the IDE. So some of those libraries you have to download and install manually. But other libraries I used are also available in the download manager. So
that is also not a complicated process. For example, I'm currently working a lot with the Arduino audio tools from Phil Schatzman, and he's always offering these as zip files. And there's another button in the Arduino IDE, just you click on it, and then you say, okay, where's my zip file? And it also automatically installs the library.
Yes, and if in one of the examples in this DSP support board support package, if it makes use of another library, it's written in the comments at the top of the sketch. And there is also a README file inside the folder of the example that has the URL to the external library. So it's normally you should have all the information all in this board's this Arduino library.
Well, you had Sigma Studio up, but we went down a Arduino IDE tangent, which was very interesting because I do have Arduino IDE running right here, right now. But back to Sigma Studio. This is the one I don't know. I've never used it. I do not have it. What is it, Clemens, and how is it helpful?
Yeah, so what we are looking now is Sigma Studio. First of all, you must know that there are 2 versions of Sigma Studio, and this is the old version. You have to have the old version because the new version doesn't support the ADAU 7001, and the old version does. And so you must use the old version. The old version goes up to, that's this version. Let me check which version it is. Share. So that's 4.7. That's the last and latest version of Sigma Studio, and it's not Sigma Studio Plus. So that's important. So Sigma Studio is a like I said, a graphical programming environment. Here we have the schematic. This block are inputs of the DSP. As you can see, it has 10 inputs, but these are actually not the audio inputs. The audio inputs are here. These are this one, for instance, these are the DSP outputs. Here we have a constant, bigger, and a mixer block, and here we have a equalizer block. So this is a graphic equalizer for band, where you type in manually the frequency. You have the settings. It's all very graphical. You connect these with virtual wires. So that's how it works.
And these sliders we have seen, is it connected then later to the potentiometers?
You can do that, but
okay.
In this example they are not. I don't think so. I don't.
In that example, you would compile and then it would just upload this filter characteristic, how you configured it here. So the sliders will be
settings for one slider. You can set the equalizer parameters.
But then you compile it and these values are fixed then in the DSP.
Yeah, yeah, like as it is this way, they are fixed.
Mm-hmm.
Let me check. We can see here this block, the GPIO block. I'm not sure if you can see it well, but my mouse is circling around the GPIO block.
Mm-hmm.
Here you can, so the 10 inputs, 10 GPIO inputs of the DSP, you can select what you want it to be. It can also be an output. Well, that's why it's called the GPIO. But they are not set, they're all set to GPIO and not to a potentiometer. This one, 2, I think. Which one are it again? Certain of these inputs can be a potentiometer analog input, but they are not used now. So in this example, we don't use the potentiometers. This is actually a tutorial that's in the second article explaining how you use Sigma Studio.
I see. What audio effects are there available in Sigma Studio? Are there also reverbs and delays and something?
Well, that's reverbs and delays that require a lot of memory, and this DSP doesn't have a lot of memory, so you cannot have a lot of delay. But here on the left in the tree toolbox, so you have here the chip, and then you have the algorithms that you can use on the chip. So we have, for instance, dynamic bass, we have pitch modification, advanced DSP stuff, transforms. So the idea is that you use these blocks to create your own audio effect.
Okay. And if I have 4 audio outputs, I could, for example, create 2 separators for the high frequency and low frequency for stereo. Okay.
Exactly. Yes, this chip, this DSP is used a lot to make audio loudspeaker separation filters with, and it's also used a lot in stomp boxes for guitars and other musical instruments. If you search the internet a bit, you can find all sorts of examples. But like it's because it's a DSP.
Did you test the audio quality in some way?
Yeah, well, I have not. I don't have super high quality audio testing equipment, so to me, it sounds fine. That's all I can say. It's not really precise, and it will not satisfy everybody, but to me, it sounds good.
Okay, so
And
we're
this is, by
just
the way,
over
if
half.
you think it doesn't sound well enough, then the board has two types of filter options. The DSP board, the output filters, you can use it comes default with active filters, but you can remove these and install instead passive filters, or add your own filters if you want to.
Okay.
Okay, time to return to the giveaway. As I said earlier to our audience, we are giving away 5 copies of this book right here, Practical Audio DSP Projects with the ESP32. So that's right on topic. Clemens, I bet you've read that one. It's by Dogan and Ahmed Ibrahim. And the book teaches the basics of DSP at a practical way using the ESP32 microcontroller and Arduino IDE, of course. So it's perfect for anyone looking into a dive into real-time DSP applications without needing a heavy background in mathematics. It includes step-by-step projects like building internet radios, text-to-speech systems, sine wave generators, and more relevant to our current topic, real-time filters. So it's a great resource for beginners and enthusiasts. Now, to enter, let's get that URL up on screen. That's it there, elektor-laptop-giveaway. And the code word that you're all waiting for is DSPFX. So that's pretty simple. Now, Clemens, you initially published this as a labs project. And I'd like to remind all the enthusiasts out there, if you have any projects that you'd like to show off, who knows, it could end up in Elektor magazine and you could become one of our partners for an article. But Clemens, you published quite a lengthy and thorough article. I'll just put that link up, elektormagazine.com/lab/audio-dsp-fx-processor. And this is very thorough. And I've gone through it, and there's one thing that I'm missing is a YouTube video demonstration of the project. Will you be giving us a demo of that anytime soon?
I don't know, maybe someone can make one.
Ah, there you go. Delegate. I like your style. Okay, so
I will also order a board, Brian. Maybe I can do something with it.
Awesome. Well, it's easier for you, Jens, being right there in Germany. Never know if I'll get it on this side of the world. So
I have one question left to that Sigma Studio, because, okay, it looks, there is a steep learning curve until you get it, how you have to wire these building blocks and so on. How is the documentation elements? Are there video tutorials or manuals or?
Well, analog devices, they have a analog university, I think they call it. So online they have quite a lot of documentation about Sigma Studio. It's quite extensive, actually. At the same time, it is not, sometimes you want info on a block and then it just say this block can do that, and that's not very useful. But they did try to put quite some documentation online. And of course, you just have to play. You start playing, and then it's
like always.
Like always, yes. But a written tutorial. Don't know if I put it on Labs, but the written tutorial will be in the second part, which will be in the next magazine, I suppose.
Now, how does the ESP32 handle audio independently and yet gain flexibility with the DSP codec?
Well, you can use the ESP to generate, for instance, to generate the audio. There are audio libraries, music libraries for the ESP32. And then you want to hear it, so you just pump it over I2S to the DSP, and sorry, and the DSP just pumps it through to the output. So then, in that case, you don't have to do any DSP programming, and the DSP program for that to do that is included in the Arduino library. So that's one thing. You can also, before outputting the audio, make the DSP do something to the signal as well, add an effect to it. So that's one possibility. You can also use the DSP to sample audio and send it to the ESP. Then the ESP can process it and send it back to the DSP, or the ESP can send it over Wi-Fi or ESP now or over Bluetooth to something else. All this is possible.
I think you haven't tested it, but I would be interested in the latency of, for example, transforming it from digital to analog and then maybe sample it back. And then you could measure the time.
Yeah, but then the latency only depends on your program. And the DSP is a real-time converter. Okay. So if you sample at 48 kilohertz, you will get your audio at 48 kilohertz almost immediately. Which is maybe a microsecond latency, and then it depends on how you make the ESP handle the buffers. If you do it in a good way, then it will be fast. If you do it in a less efficient way, then it will be slow. So there is no definite answer to that. It all depends on the software that you develop.
Okay.
Yeah, well, we do ask selfish questions, Clemens. I know Jens is all about latency because he's working on projects that latency is very important to him. And of course, I ask about voltages and opto-isolators and that because of what I'm working on. Last time I connected an Arduino directly to a keyboard MIDI, that was fine because they were both 5 volt TTL. But as you mentioned, and I'll reiterate for the audience, MIDI has built in an assumption that all inputs will be opto-isolated, correct?
Well, if you adhere to the MIDI standard, then yes, that is the whole point. It was designed to connect all sorts of equipment from any manufacturer in a safe way. So that's why they put in an optocoupler.
Well, I better get some optocouplers in stock here so that I stop trusting and hoping for 5 volt tolerance. Now,
yeah, well, I published a MIDI interface some years ago, a small module with compatible with 5 volts and 3 volt 3 drivers, and with different connector options.
With any luck, I can find that now. But what does the MIDI do in the project? You've shown DSP quite thoroughly. I mean, that's a 4-band equalizer you're showing off there for the DSP section and in Sigma Studio. But what can you trigger? What can you do with MIDI signals going into the board?
Well, the MIDI signals, the ESP32, I added it has a 2-channel analog converter, and because the DSP can have 4 analog inputs, control inputs, not audio inputs, I added a 4-channel, or I turned the 2-channel analog converter into a 4-channel. And so you can use MIDI, you can use the ESP to convert MIDI signals to voltages and then control the DSP. That's one way. But there is another way. There are people who have reverse engineered parts of the DSP algorithms. And so you can also over I2C control certain parameters. And you could do that with MIDI as well. So you convert MIDI to I2C, and then you can control some parameters of the DSP.
So that's very flexible.
Those options are available. You can also go the other way around if you like, and in theory, use the potentiometers to send MIDI data to something else. So you can also use it as a MIDI generator.
Awesome. But that's to the questions, and yes, I encourage everyone to bring your questions. We've got about another 15 minutes left, so we can take the questions. Gerhard Schul says, can you repeat the code? Yes, I believe we can. That's the code right there. And that's the competition page for the Elektor giveaway of this book, Practical Audio DSP Projects with the ESP32. So if you visit the link on your screen, the code word is DSPFX. So good luck to everyone who's clamoring to enter. That looks like a very interesting book to me as well. One thing I've never dabbled with, Clemens, is I2S or I2S, depending on who you're speaking to. Transferring audio around in sort of an I2C formulation, it seems...
No, it has nothing to do with I2C. I2S is just a stream of bits. It's just a continuous stream. No addressing or anything. It's just a stream of data and a clock, and it can go very fast.
The clock line is separate.
You can have several formats. That makes it a bit complicated, of course. You couldn't stick it to keep it in to one format, so there are several formats. It's an interesting point actually for this board, because by default the DSP it works on its own. It does its own thing, and if you want to use it as an I2S master, I2S is also a master-slave protocol. Then the ESP must be slave, but when I don't know how far they are now, but at the time the ESP32 slave I2S was not implemented, so I had to go the ESP32 master way, which is complicated with the DSP, as it turned out, because the DSP can only be a slave if you get all the signals right, and if you mess up one signal, then there is no sound anymore. So on the board, luckily the ESP32 can get the signals right, so that was good. So, but this is why on the board you have a clock select option here. If you want the ESP32 to work with I2S audio, then you have to place the jumper in the external M clock position. This is related to the DSP. And if there is no I2S communication between the ESP32 and the DSP, then you have to put it on the X1 position, which is the board's crystal. That ensures that I2S master, ESP32 as I2S master, works with the DSP. And it happened to me often that I didn't get any sound, and it was because I forgot to put the jumper in the right position.
And I'm seeing it as similar to I2C, not because it's addressing modes and that, but it's basically a data line. And is there a separate clock line?
Yes.
Yeah, you have
different ones.
You have different. It depends on the format, but you have left-right indication and a clock line and
bit clock and the master clock.
Yeah. It's really, you should not compare it at all to I2C, because I2C is just a data communication protocol with addressing and stuff, error correction. I2S is just a raw, it's more like SPI than I2S. It's just the naming is the naming is a bit unpractical.
So it's more like SPI, got it. And apparently it's capable of quite a high bandwidth. So you could theoretically take raw CD audio, 16-bit, 44,100 samples per second stereo, and you could pass that over. Is that right?
Yeah, that's easy.
Even more.
Low bandwidth, on the low side.
Wow. Could you do 6
I think the
channel
DSP,
audio?
I'm not sure, but you can go on the ESP, you can go up to 192 kilohertz or something.
Wow. 192
The DSP defaults to 48 kilohertz.
Okay, so can you do 190 kilobits at 32 bits a sample in stereo? How far can you push it? That's what I'm trying to get.
I'm not sure about this board, but I2S, yes.
Mm-hmm. Yeah,
excellent.
32 bits per sample, and
yeah, this DSP is 24 bits actually.
Got a nice wow emoji response from one of our audience members. I agree. You may not know this offhand, Clemens, but Wilfried Kubeling is asking, do you have a type number for the Hammond enclosure?
Yeah, because it's printed on it.
Ah, there you
this
go.
One, the black one, is the 1593N, 1593 Nicholas.
And enclosure number, I'm just dropping it in the chat here.
And then the N means is for black, I think. And
wow.
So the translucence changes a bit. You have to be careful with these numbers at Hammond, because they use often the same number for different sizes, etc. You have to be. But if you look for 1593N, then you should find this one.
Great. Well, there's your answer, Wilfried. Question again from Karen. How does Signa DSP work in cars? I'm not sure we could answer that, but what sets the audio DSP FX process apart from others?
In cars, Sigma DSP has nothing to do with cars. It's just a DSP programming language tool. But of course, you can use this board in a car if you like. What this board sets, this board differs from other boards. You have other boards with an ESP32 and an audio codec. Is that on this board you have the DSP, the audio codec is a intelligent audio codec because it has a DSP inside, and so the codec itself can do signal processing. So it has more signal processing power than just a processor with an audio codec.
Yeah, and I wouldn't like to be fiddling with a MIDI controller in the car either. I found your article, by the way, Clemens. I'll put that up on screen. Did a quick search. There's your MIDI I/O rackout board. Supports DIN and TRS connectors. That's great.
Yeah,
That's really useful.
This module, you can configure it as an input or an output, and you can use it with and without optocouplers, and you can use it with DIN and with TRS and whatever you like. So the schematic is just below.
And you said it was released, the specification was released in the summer of 2018, and you mentioned TRS, but you also mentioned earlier TRRS. I see there in the schematic, you can see TRS on the top, tip ring sleeve, and then at the bottom tip ring and sleeve. What's going on with that? What is the extra ring for?
Well, on this module,
let me zoom in.
TRS.
Yeah, there's a TRS at the top, K3, and K2 at the bottom. It looks
not
like
connected.
No, it's not a TR. It has a switch.
The switch. Okay.
No, it's on the DSP board that it's TRRS because I wanted to use the same connector for audio and for MIDI.
Okay, that makes sense.
But so the second R is not used.
Great. So just for the purpose of keeping the same connector. I remember designing a board based on a switch that I had in stock, and then I had 100 of the boards made, and nobody could get that switch. So I couldn't get a switch that fit in there because that just happened to be the switch I had, and I wanted to use that. Question, of course, logged in late. Will this webcast be available later? Yes, indeed, Tyler Hopster. It will be on, for example, our YouTube channel, but you can catch us on Facebook as well. But shortcut to get to our YouTube channel is just elektor.tv, and you'll be dropped into the channel. Just click on live, and this will be there for you. We've got about 5 minutes.
Brian, there's one question about the availability in the shop.
Yeah, that one. Let's find that one. Elektor store says the board is out of stock. We're not sure when it will be available again. Clemens, have you heard anything? It's a very popular.
No, I didn't know that it was out of stock. So.
Okay, we'll have to press our store and see what we can do, because Jens wants one. I wouldn't mind one, and of course our viewers are checking it out as well. Before we wrap up, had a look at the questions from the audience. Jens, did you have any further questions for Clemens?
No, not at the moment. I'm looking forward to also have one in my hands. And yeah, I'm currently working on audio transmission with ESP now. And yeah, I think that board will also work for that. And then I will take some measurements. And I'm sure I will let our readers know about it, maybe in a labs project.
And I know this is not the project, but I'm liking this. It's got the opto isolator, opto couplers, and the TRS and the 5-pin DIN, depending on the module. So yeah, very cool project, Clemens. Even if I could just get a bare board and put it together myself, that'll be great. Anyway, I think that's all the questions from the audience. Jens and I have extra reading to do after the show because it's been a very interesting one. And yes, we've got some links that we'll put in the YouTube description afterwards because there are a lot of questions that come through and we can't always answer them real time. But that's what the YouTube description box is for. We'll dump in some links and some extra information. We'll put in the Hammond enclosure number for everyone. But on that, we've got 2.5 minutes left of the hour. So I would like to thank our audience from around the world. And I've seen you from around the world, as always. I have a very great audience in different time zones. Yes, comment that just came in. Thanks, guys, for a very interesting webinar again. I have 2 of those boards for my custom synthesizer project, and they are really great. Well, that's great, Puzzy. Let us know if you're interested in selling them because Jens and I are both one-to-one now.
Don't sell them, but maybe he wants to share his project.
Yes, do that.
It would be
Go
cool
to
to
Elektor
post it on Elektor Labs.
That would be awesome if you did do that, because you're using 2 for a custom synth. I'm getting excited just reading that. Anyway, I'd like to thank our guests. First of all, Elektor Editor-in-Chief, Jens Nickel, for joining us because he had burning questions that just could not wait. He's very into audio. And like I said, latency is an issue. Well, for me, it's moving the digital signals around in MIDI at the moment. And the expert who brought us all here and designed this all, the genius mind that is Clemens Valens. Thank you for joining us.
You're welcome.
And to the comments section, please join our giveaway. You can always rewind the video. I'm not going to put it up again, but good luck. We've got 5 of those books to give away, and they should be rather entertaining and rather educational. So good luck to those of you who are entering. And thank you to everyone from around the world, including Clemens and Jens, for joining us. And good night, good afternoon, good morning, wherever you are.